Hi friends, in this lecture related to current electricity, first we will understand the mechanism of current flow, then we will come to the few terms related to flow of current, first free path, then mean free path, then relaxation time, mean relaxation time, drift velocity, and then we will obtain an expression for drift velocity, and afterward we will find out the relation between electric current and drift velocity. So be ready with your pen and notebook to note down the important points, and then at the end of this lecture we will solve the few numericals related to these. First we will understand why there is no current until a potential difference is applied across the ends of a conductor. Also, before that, we should be knowing what is meant by conductor. Conductor means a substance that has plenty of charge carriers, and in metallic conductors charge carriers are free electrons, and these free electrons are produced due to the thermal excitation. It means the energy gained by free electrons at room temperature is enough to make them free from the attraction of nucleus, and when these electrons become free from the attraction of nucleus, they begin to move throughout the volume of conductor in random directions, such as the molecules of a gas. It means the free electrons within a metal behaves like the molecules of a gas. Hence, the collection of free electrons within metal is also termed as electron gas. When there is no potential difference across the ends of conductor, these electrons being moving in random directions, the net charge transferred through any section of conductor in either direction will be zero. It means if we are considering a section of conductor, then number of free electrons passing the section from left to right in a certain interval of time will be equal to the number of free electrons passing through the same section from right to left in the same interval of time, such that the net charge transferred through any section of conductor is zero, because the net displacement of free electrons through the conductor will be zero. Net displacement zero means the average velocity attained by free electrons due to thermal excitation is zero. It means if the individual free electrons present in the conductor have thermal velocities u1, u2, u3, so on. If total number of electrons is capital N, then the velocity of last electron will be un. And if we come to the average thermal velocity of all the electrons, then u average will be equal to the sum of all the velocities attained by free electrons due to thermal excitation divided by total number of free electrons. So it will give us the average velocity attained by free electrons due to thermal excitation, and we know that only due to thermal excitation there is no current through the conductor. It means there is no net displacement of free electrons in either direction. Hence, the average velocity of free electrons due to thermal excitation must be zero. So this must be zero. Now, in the absence of potential difference, there is no current through the conductor. Then how current begins to flow through the conductor when potential difference is applied? Say it is a conductor, a potential difference is applied across its ends, then on applying potential difference, one end of the conductor will become positively charged, another end will become negatively charged. Potential difference applied is V, length of the conductor is L. Then this potential difference will establish an electric field within the conductor, and that electric field E is V upon L. Whenever a charge will be placed in electric field will exert a force on that charge. Hence, we will have to find out what are the charges present in the conductor, and the charges present in conductor are the free electrons and the positive ions formed when atoms lose their electrons to produce free electrons. It means the only charges present in the conductor will be in the form of free electrons and positive ions. Positive ions, being atoms after losing free electrons, will not be free to move, because in solids atoms cannot move. So the effect of force exerted by electric field on free electrons will be there, but there will be no effect of force exerted by electric field on positive ions, because they are not free to leave their positions. So due to the force applied by electric field on positive ions, there will be no change in the positions of positive ions, but due to that force, these free electrons will begin to move along the length of conductor, and these free electrons will experience force towards positive end of the conductor. So they will begin to move against the direction of electric field, because electric field is always directed from positive to negative terminal. So they will begin to move towards positive end, it means against the direction of electric field. Due to this force experienced by free electrons due to electric field, the free electrons will attain a velocity along the length of conductor towards its positive end, and this velocity will be termed as drift velocity. So drift velocity is the velocity attained by free electrons along the length of conductor when a potential difference is applied across its ends. Thus, beside the random motion due to thermal excitation, a motion due to electric field will superpose over the electrons along the length of conductor. Now, to obtain the expression for drift velocity, we will be requiring a few terms. First is free path, when free electrons will move along the length of conductor, then during the course of their motion they will collide with the positive ions present in the conductor and also with each other, and during these collisions they will lose their energy, and again to make them move they will draw energy or take energy from the source. Thus, source will supply energy to free electrons so that they may continue to move towards the positive end of the conductor, and this obstruction offered by positive ions as well as other free electrons to the movement of free electrons, that is the movement of charge carriers, is called resistance offered by the conductor. So the cause of resistance will be the obstruction offered by positive ions and other free electrons to the movement of a particular free electron along the length of conductor. And during two consecutive collisions, free electron will travel a certain distance, and that distance traveled by free electron between two consecutive collisions will be called free path, and this free path will not be same for all free electrons present within the conductor. Hence, we will take the average path length covered by free electrons between two consecutive collisions, that is the sum total of free paths of all the free electrons divided by total number of free electrons, that is the mean of all free paths will be called mean free path of free electrons. Thus, mean free path is the average distance covered by electron between two consecutive collisions. Now, relaxation time. Relaxation time means the time interval in which free electron covers free path. It means it is the time interval between two consecutive collisions suffered by a free electron, and again it will not be constant for all free electrons. So we will take average of relaxation times for all the free electrons, and if the relaxation times for various free electrons are tau 1, tau 2, tau 3 and so on up to n, then the average relaxation time will be obtained by the mean of these relaxation times, and that mean relaxation time will be represented by tau. So tau will be sum total of all the relaxation times for all free electrons present in conductor divided by total number of free electrons. Now, drift velocity, already I told you the velocity attained by free electrons along the length of conductor when a potential difference is applied across its ends. So we will come to the expression for drift velocity, and for this first we will have to calculate the acceleration of free electrons when a potential difference is applied across its ends, and this acceleration will be in the direction of electric force. Direction of electric force will be the direction of electric field. So now first we are coming to the acceleration of free electron. Acceleration of free electron on application of potential difference will be electric force on free electron divided by its mass, because F is equal to ma, and acceleration as well as force will be vector quantity. So this implies magnitude of acceleration A is equal to magnitude of force upon mass of electron, and this implies A is equal to electric force is given by magnitude of charge multiplied by electric field. It means E into E, because charge is electronic charge E, magnitude of electric field is E upon M, and we know that electric field can be written as potential difference per unit length, so it will be EV upon ml. So EV upon ml will give us acceleration of electron, and from here we can see electronic charge, mass of electron, potential difference, length, all are constant. If all are constant, then it means acceleration is constant, and if acceleration is constant, then for dealing the motion with constant acceleration we will be having four equations of uniformly accelerated motion. So we will use here the first equation of motion to determine the velocities of different free electrons on application of potential difference. Say these velocities for various free electrons are V1 for the first electron, then this first electron will be having the velocity due to thermal excitation as U1, and U1 will be present even in the absence of potential difference. So U1 will be the initial velocity, and V1 is equal to U1 plus A, and time interval for which this first electron was free to move is tau 1. So A tau 1, V2 U2 plus A tau 2, and so on. In this way we can find out the velocities of various electrons after application of potential difference. So the average velocity of free electrons after application of potential difference along the length of conductor, that is drift velocity, will be given by the sum total of all these velocities, that is u1 plus u2 plus so on up to un plus a common tau1 plus tau2 plus so on plus up to tau n, and it is the sum total of velocities of all the free electrons divided by total number of free electrons. Here it should be capital N because the number of free electrons we have taken as capital N. So this can be divided into two parts, u1 plus u2 plus so on up to un divided by capital N plus a common tau1 plus tau2 plus so on up to tau n divided by capital N. Now from first, average velocity of free electrons due to thermal excitation will be 0. So Vd will be 0 plus a tau, and this implies Vd is equal to a tau, and here it shows the direction of drift velocity will be same as the direction of acceleration of free electrons, and free electrons will be accelerated towards the positive end. So drift velocity will be towards the positive end, and this implies magnitude of drift velocity Vd is equal to a into tau. And what is a? A is E by m, so you may say E tau by m or EV tau upon ml as the expressions for drift velocity. Now we will come to the relation between electric current and drift velocity. If we come to the relation between electric current and drift velocity, we will assume three sections of conductor, and these three consecutive sections are separated by a distance Vd. Why distance Vd? Because Vd is the distance covered by free electrons along the length of conductor in 1 second. And if Vd is the distance covered by free electrons along the length of conductor in 1 second, and say the names of these sections are P, Q and R, then all the free electrons lying on section R will reach at section Q in 1 second, while the free electrons lying at section Q will reach at section P in 1 second, because in 1 second the distance covered by free electrons will be equal to the drift speed of free electrons, and drift speed is Vd. So all the free electrons lying between sections Q and R will reach between the sections P and Q in 1 second. As the free electrons lying on Q were reaching at P, while the free electrons lying at section R were reaching at Q. Since all free electrons lying within the sections Q and R are crossing the section Q to attain their positions in between sections P and Q, we can say that in 1 second all free electrons within the length Vd of conductor will cross the section Q, and amount of charge crossed through any section in 1 second is electric current. So if we will get the number of free electrons passing through section Q in 1 second, then that number of free electrons multiplied by electronic charge will give us the current. If number of free electrons per unit volume of conductor is small n, then we can find out the volume of conductor between any two consecutive sections separated by distance Vd, and that volume will be area of cross section A multiplied by Vd. So A Vd will be the volume of conductor with length Vd, and hence the free electrons contained by this volume will cross any section of conductor in 1 second, and those free electrons, since in unit volume number of free electrons is n, then the number of free electrons in volume A into Vd will be n into A into Vd, and these free electrons will cross any section of conductor in 1 second. So amount of charge passed through any section of conductor in 1 second will be current. This will be equal to amount of charge contained by a length Vd of conductor, and number of free electrons in unit volume is n. So n multiplied by volume of conductor with length Vd, that is AVd, will give us the number of free electrons passing through any section of conductor in 1 second, and this number of free electrons multiplied by charge possessed by 1 electron will give us total charge passing through any section of conductor in 1 second when a potential difference will be applied across the ends of conductor. So I is equal to NEAVD will give the current passing through the conductor, because charge of 1 electron will be E, and amount of charge passing through any section of conductor in 1 second will be current. So it is the relation between current and drift velocity. Say it is third, it is second. These two relations will again be required when we will be proving Ohm's law theoretically. Now, to strengthen our knowledge gained from this lecture, we are going to solve two numericals. And say the first numerical, a current of 5 ampere is passing through a metallic wire of cross-sectional area 4 into 10 to the power minus 6 meter square. If number density of free electrons is 5 into 10 to the power 26 per meter cube, find drift speed of free electrons. This question was asked in Roorkee Engineering Exam in 1991, and now first we will note down what are the quantities given in the question. The quantities given in the question: first electric current 5 ampere, then cross sectional area A 4 into 10 to the power minus 6 meter square, then number density of free electrons N 5 into 10 to the power 26 per meter cube, and we have to find drift speed Vd. And for this we will be requiring the relation between current and drift speed. We know the relation is I is equal to NEAVD, where E is electronic charge. So this relation will give Vd is equal to I upon NEA, and this gives Vd is equal to I means 5 upon N, 5 into 10 to the power 26, and E 1.6 into 10 to the power minus 19, A is 4 into 10 to the power minus 6. 5 will get cancelled with 5, 10 to the power minus 6 minus 19, 10 to the power minus 25, 10 to the power 26, that is 10. 10 into 1.6, 16. So it will be 1 upon 4 into 16. And if we want to change it into decimal, then it will become 100 upon 64 into 10 to the power minus 2. And this will be 4, 16, 4, 25. 25 by 16 into 10 to the power minus 2. It means Vd is equal to 25 by 16, 16 1 ja 16 point, 90, 16 5 are 80, and then 100, 16 6 are 96, 1.56 into 10 to the power minus 2 meter per second. Now we are coming to the second question, and this question is the area of cross section, length and density of a piece of a metal of atomic weight 60 R. It means first area of cross section, and then length, then density, and here it is atomic weight. So when we come to the solution, we will first note down all the quantities which are given in the question. Area of cross section is 10 to the power minus 6 meter square. Length is 1 meter. Density rho is 5 into 10 to the power 3 kg per meter cube, and atomic weight, that is mass number, is 60. Then find number density of free electrons. It means n is to be found if each of its atoms contributes one free electron. It means number of free electrons per unit volume will be equal to the number of atoms per unit volume of metal, because each of its atoms is contributing one free electron for conduction. Also find drift velocity of electrons. It means afterward we have to find drift velocity. It means Vd is also to be found, and the electric current passing through it is given as 16 ampere. Also Avogadro number Na is given as 6 into 10 to the power 23, and it is 6 into 10 to the power 23 per gram mole. But in SI units we require this number in per kilogram mole, and for per kilogram mole it will become 6 into 10 to the power 26. So 6 into 26 atoms per kilogram mole. This question is also asked in Roorkee 1994. Now how to find number density of free electrons? It is given in the question, number density of free electrons is equal to number density of atoms in the metal, because each metallic atom is contributing one free electron for conduction. So whatever will be the number of metallic atoms per unit volume, same will be the number of free electrons per unit volume. Now for this we will be requiring the number of moles in unit volume of metal, and number of moles in unit volume of metal means the mass of unit volume, and mass of unit volume is density rho. So mass of unit volume divided by molar mass will give the number of moles in unit volume of metal, and in 1 mole number of atoms is 6 into 10 to the power 26. So in this much mole the number of atoms will be multiplied by Na. So it will give us the number of atoms per unit volume of metal, that is the number of free electrons per unit volume of metal, and this means rho, which is 5 into 10 to the power 3 divided by molar mass will be 60 kg, and Na 6 into 10 to the power 26. 6 will get cancelled and we will be left with 10 here, and 10 to the power 26 or 3 29 upon 10, So 5 into 10 to the power 28, and it will be per meter cube. So this will give us the number of free electrons per unit volume of metal. Now we want to find out the drift speed. Then we know that I is equal to NEA VD. So VD is equal to I upon NEA, implies VD is equal to I is 16 upon N we found as 5 into 10 to the power 28, E 1.6 into 10 to the power minus 19, and A 10 to the power minus 6. 1.6 10 ja 16 and 5 2 ja 10, and here minus 19 minus 6 minus 25 plus 28, 10 to the power 3, and 10 to the power 3 when will come to numerator will become 2 into 10 to the power minus 3 meter per second. So 2 into 10 to the power minus 3 meter per second will give us drift speed of free electrons. Here in this question we can see that L is not used in solution, because if we will determine mass using volume into density, and then that mass will be converted into number of moles, then number of moles per unit volume. So for calculating per unit volume, that AL will get cancelled with AL. So directly, instead of using AL and again dividing it by AL, we have directly used the mass of unit volume, that is density, divided by molar mass will give us the number of moles in unit volume, and number of moles in unit volume multiplied by Avogadro's number will give us the number of atoms in unit volume of metal.